All right, hello Calculus 1 class. Welcome to Learning Online. I thought we'd start and just go over what we covered in class very briefly in this video, and then in the next part of this series, then we'll go on and do some new things. So in class, we started by looking at examples like example 1, and even though the form here was 0 over 0, which was indeterminate, we were able to use algebra to simplify and then work it out, and we got a half. Example 2, same thing, 0 over 0, but using a proof by picture. Way back in the beginning of the course, we got 1. But example 3 sort of pushes us to the boundary of our abilities here. We're no longer able to use algebra or pictures to solve this. Notice the form, 0 over 0, but we were stuck. So we introduced L'Hopital's rule. I won't go over it again all in detail, but the takeaway is if you have the limit of a fraction, and the form is either 0 over 0 or plus or minus infinity over plus or minus infinity, then the limit of the fraction is equal to the limit of the fraction of the derivative of the top over the derivative of the bottom. You're not using the quotient rule. You're literally taking the derivative of just the top over the derivative of just the bottom. So it really simplifies things nicely. We pointed out in class that it's valid for one-sided limits and even limits at plus or minus infinity. We also pointed out when you use it, you should indicate to your reader with an L over the equal sign where you're actually using it. Mathematics is half computing correctly, and it's also half communicating. So we want to communicate what we're doing by an L. And then I believe we mentioned this, I'm not sure, but 0 times infinity, infinity minus infinity, 0 to the 0, 1 to the infinity, infinity to the 0. These are all indeterminate forms. So if you see one of these, you instantly know you need to do more work. And a lot of times, there's going to be an algebraic way to manipulate these indeterminate forms back into something that L'Hopital can handle. So we'll see that as we go on. So here's the examples that we did. I'm not going to work through them in detail. 1 and 2, we're just applying L'Hopital's and just practicing, and then you got it. 3, there was an important note that we made on example number 3 last time. Look, when you apply L'Hopital's rule the first time, you get to here. And if you're not careful, you'll realize that, hey, the form here, as x goes to infinity, the top goes to 0, the bottom goes to 0. I can do L'Hopital's rule again. But as we said in class, that doing that is going to lead you to just do it again and again and again and again. And it's like falling off into an infinite pit of badness. So before you apply L'Hopital's rule again, you want to simplify first. So we simplified this, we got to here, simplified all the way to there, and then we realized, oh gosh, the limit's just 0. So that was that one. The last trick that we saw last time in class was this problem. Here's an example where we're actually going to change form. So the form starts out as x goes to 0 from the right. This part, x goes to 0. ln of x shoots down to minus infinity. So the form is 0 times minus infinity, indeterminate form. Not in L'Hopital's form, right? I need a 0 over 0 or a infinity over infinity to be able to use L'Hopital's rule. So the trick was to algebraically manipulate this and flip one of the products downstairs. We chose to flip the x downstairs. X is the same as 1 over x. These are the same algebraically. Now we can apply L'Hopital's rule because the form as x goes to 0 from the right, ln goes to minus infinity, 1 over x goes to infinity. And so we apply L'Hopital's rule. Here we go, we simplify, and the whole thing is 0. We also pointed out, last detail, anytime you see natural log in a limit and it's indeterminate, you should sort of always bet against natural log. As in, I can look at this, and if I can tell you that I would very much expect the answer to be whatever x does. X goes to 0. I can tell you right now, on number 3, I expect the answer to be whatever the 1 over root x does. You just sort of replace ln of x with a 1 in some sense and watch what happens. And you expect in both cases the answer to be 0. If you just write that, that's how many points you're going to get, right? I want to see you reason it out and get it correct. So next video, we'll keep going with some